Today's topic is the determination of order of the reactions. And you know what do you mean by the order of the reactions? And the order of the reaction is nothing but the concentration terms, which decide the rate of the reaction. The order may be zero order or integer or it may be fraction. And for elementary reactions, for example, it is an elementary reaction, let us assume. What do you mean by elementary reaction? That elementary reaction is one which takes place in a single step, we call it as the elementary reaction. In elementary reaction, the stoichiometry of the reactant itself is equal to the order of the reaction. Therefore, the reaction is a second order with respect to A and first order with respect to B. Therefore, total order is 3. You all know it. But if this reaction is a complex reaction, what do you mean by complex reaction? If the reaction takes place in more than one step, then it is called the complex reaction. In such cases, you should determine the order of the reaction in the slowest step which is possible in the various steps of reaction. But the rate equation should contain the concentration of the reactants and or the concentration of the product, but it should not contain the intermediate concentration. That is the condition. Therefore, for complex reaction, you have to derive the rate law equation. But for the elementary reaction, you can simply say the rate equation for MA plus NB for elementary reaction as rate law is equal to K into the concentration of A power M into the concentration of B power N and so on. It is for any elementary reaction. Now we are going to see for the elementary reaction how the rate law equation is used to calculate the order of the reaction. And the order of reaction is generally determined first to one by graphical method. And various order of the reaction would be having various graphical representation. And if you want, we also have the problems in the graphical representation. From the graphical representation, we can determine what is the order of the reaction. You might have come across in the determination of the order of the reaction in ester hydrolysis in your physical chemistry experiment. And second is from the unit of the rate constant. From the unit of the rate constant, you can determine the order of the reaction. With these problems in this, we have already seen. And the third thing is from the T-half method. The T-half method, we are going to see the problems in the next few minutes. T-half method. Fourth method is initial rate method. Initial rate method. What do you mean by initial rate of the method? In this method and this method are useful to determine the order when only one reactant is present. When multiple reactants like A plus B plus C are present, the method, the graphical method cannot be applied. For such cases, initial rate method is applied. The initial rate method, what is the basic principle? Keep the concentration of the other two, if the concentration of the other two reactors is the same, vary the concentration of A and find the order of the reaction with respect to A. Then keep the concentration of other two, both B and C are kept constant. Now keep the A and C constant, vary the concentration of the B, find out what would be the variation of this rate. Accordingly, you can determine the order of the reaction with respect to B. Then keep the concentration of A and B constant, vary the concentration of C, from which you can find out order of the reaction. In some other questions, after finding the K, you find out the rate of the reaction when the concentration of A and B are this one. Therefore, here, by this method, you can first find out the order of the reaction. After finding the order of the reaction, you may be asked to calculate, give the rate law equation for this reaction. After finding the rate law equation, you may be asked to calculate the rate constant of the reaction. And the concentration of A and B would be given, and the K you have already calculated. Then find out what would be the rate of the reaction at a given concentration. Therefore, 4 types of problem may be asked from the initial rate method. And fifth method is the experimental method. The experimental method, simpler method you have carried out in your course PG program, determination of the ester rate constant for ester hydrolysis and so on. Sixth is the Van Hoff differential method. Van Hoff differential method. This Van Hoff differential method is more or less similar to this method, initial rate method. And seventh is the Oswald isolation method. Oswald dilution but isolation method. What is the difference between these Van Hoff differential method and the Oswald isolation method? In Van Hoff differential method, we are keeping the concentration of B and C as a constant. We are varying any one of the reactants concentration, varying and determining the change of the rate, and from this we can calculate what is the order of the reaction. In Oswald's dilution method, we are taking the concentration of the remaining reactants as excess or infinity. Whenever you are taking excess quantity, now the rate does see depend upon the excess quantity reactants. You might have studied in your theory, and such reactions you call it as the pseudo order reaction. Now the A is isolated from B and C. You can now vary the concentration of A, find out the order with respect to A. Then keep the other two reactants concentration in log excess, vary the concentration of B. Therefore, this method and this method are entirely same, but here we are keeping the concentration at a low quantity. In Oswald's dilution, we are taking that concentration of the fuel in a large quantity. Therefore, now we are not going to see the experimental technique, or sometime it may be asked, or we will see the experimental technique problem. Van Hoff differential is more or less equal to Oswald's isolation method is equal to this one. Therefore, in this order determination, you are going to use which type of method? Graphical, unit of the K, T-Hoff method, initial method. This method we have already seen. Now we are going to see the initial rate method. And the initial rate method, how many reactants are given for the reaction? Suppose A giving the product. Find out the order of the reaction with respect to A. If you are asked to calculate only one reactant order, you might have two rate law equations. Two rate law. Rate at one condition and the rate at the another condition. Therefore, two set of equations is there. Whenever two set of equations is there, we can calculate order of one of the reactants. Suppose you are given A plus B giving product. You are asked to calculate what is the order with respect to A, what is the order with respect to B. Now you should be in need of rate is equal to 3 equations are needed to find out the order with respect to 2 reactants. Similarly, you can go for a 3 reactant reaction for which you are in need of 4 equations, 4 set of data. And all this can be easily manipulated. We can see what is the method to be adopted in solving the problem in our class purpose, and what is the shortcut method to solve this problem in the CSIR examinations. So take down the problem. You will give one by one. Take down the problem or your reaction. Or your reaction. A giving product. A giving product. Or a reaction A giving product. The rate of reaction increases 5 times. The rate of reaction increases 5 times. When the concentration of A increases by 3 times, concentration of A increases by 3 times. What is the order of the reaction? Option A, 0.8 order, B, 1.2 order, C, 1.5 order, D, second order reaction. Here we are going to see, calculate only one reaction order. Therefore, we are need of how many equations to solve? 2 rate law equations. This already given that what is the rate law for this is? The rate law for this is rate is equal to K into A power M, is the order of the reaction with respect to B. And now assume that rate is equal to R, A is equal to K and A power M. This is a basic equation. Let us take it as the first equation. And then we have to change the concentration of A. They have changed the concentration in how many ways? The concentration of A is increased by 3 times. That means they are increasing the concentration 3A power M. When the rate increases 5 times, that is 5 into R. Do you understand the data? Now that data has been incorporated in the way of the rate law equation. Do you understand how I have incorporated the values in a rate law equation? Now you are having 2 set of equation. Divide one side by another. Let us divide 2 divided by 1. எப்படி இதை எடுக்கிறோம்? Which is having higher concentration. Take it in the numerator. Which is having lower concentration. Take it in the denominator. Then you will get, and just reverse or in this way, you can write pi r by R is equal to K into 3A power M by K into A power M, or R and R cancelled, K and K cancelled. Then 3A, here A and A is cancelled, therefore it is equal to 5 is equal to 3 power M. 5 is equal to 3 power M. Now what is M? For which you have to use your own calculator. Take log on both sides. Log of 5 is equal to M into log of 3. You are asked to calculate M. Therefore, M is equal to log 5 by log 3. What is log 5? Equal to 0.7. Log 3 is equal to 0.48. Therefore, the value would be nearly 22.1 point. The value is 2. It is equal to nearly point. Therefore, 1.5. Therefore, what is the answer? C is the answer, by which you can easily calculate this. Sometimes, if the equation is arriving just like this, 2 power n, you can easily manipulate this. I'll convert this 4 to the base as a base function of q. It can be rewritten as 2 power 2 is equal to 2 power n. Therefore, n is equal to second order. N is equal to second order. Suppose you are given 2.8 equal to 2 power n. Let's suppose an equation is arrived like this. You can easily manipulate this. The 2.8 can be written as 2 into 4 point something, or 4 point something would be becoming 2 power n. 2 into 1.4 is nothing but, yes, is equal to 2 root 2, because 2 root 2 is equal to 1.414, I think. So, therefore, 1 point can be written as 2 root 2, 2 power n. 2 power 1 into 2 power half is equal to 2 power 3 by half, 3 halves, 2 power n. Therefore, what is n? N is equal to 3 halves. For the calculations without the calculator, generally the values would be like this. If the values are happening like this, you can also do the problem without any calculator, for which if base function cannot be related to each other, go by the calculation, take log on both sides. And this is the methodology we are adopting in the class purpose. Now I have taken only one reagent for the determination of one order, but in CSIR, this one order reaction is not asked in 4 marks question. It may be asked in the 2 mark question. And now how to, in the next problem I will tell you, how to apply the same problem for the CSIR examination, because it will take a lot of time. Time management is very, very essential in attending the CSIR examination. Take down the problem in which I'm not going to use the methodology I have used for the previous problem. That is class purpose, we are solving the equation. Instead, we will go by the shortcut method. For a reaction, A plus B giving product. The rate of reaction increases 2.25 times when concentration of A increases 1.5 times. Concentration of A increases 1.5 times. And there is no change in the rate of the reaction when concentration of B increases 1.5 times. Concentration increases 1.5 times. What is the rate law equation? What is the rate law equation? Option. They are not asking you to write down the order of the reaction, but they are asking you to give the rate law equation. R is equal to K into A into B. This is the first option. Second option, R is equal to A power K into A power 1.5 and B power 0.5. And C option, R is equal to K into A power 2 into P power 0. And D option, R is equal to K power A into B power 0. Which is the correct option you have to find out. And look out the variations given in the problem. When the concentration of A increases 1.5 times, the rate is increased to 2.25. If it is given like this, you can easily give that rate law equation we have already given in a smooth way. Take the concentration in the left hand side and the rate increase in the right hand side. Yet concentration of A is increased. Let us assume that the order of the reaction with respect to A, B, M. Therefore, A power M is equal to, and the rate is increased 2.25 times. Therefore, the R and R cancel and you will end up with this type of equation. If you apply the rate law equation and finally 2 divided by 1, you will coming across this. I think you understand this. What is the concentration changes? Write down this and let us assume the order of the reaction with respect to reaction is M. Here the concentration is increased 1.5 times. Therefore, concentration increases 1.5 times. Therefore, it is equal to 1.5 times our M is equal to 2.25. What is the value of M? And if you easily manipulate this, 1.5 into 1.5 is equal to, you should convert into 2.25 for the base of the 1.5. It is nothing but 1.5 power 2. Therefore, what is the value of M? M is equal to 2. Second order. It is the equation. You know necessity of calculating the order with respect to B. Or you can go by this second variation. As the concentration of B increases 1.5 times, there is no change in the rate of the reaction. For which order there will be no change, whatever may be the concentration change, zero order. If you go by this zero order reaction, here also zero, here also zero, of these two you have to find out which is the correct one. Then you should go for the next concentration term. I think you have followed this shortcut method you have adopted. If you have followed this one, now work out this problem for a reaction. For a reaction, A2 plus B2, A2 plus B2 giving 2AB. The following data are obtained. The following data are obtained. Serial number, concentration of A2 in molar, concentration of B2 in molar, initial rate in molar per second, capital M, molar per second. First, 0.01 molar, 0.01 molar, 1.2 into 10 power minus 3. Second, 0.01 molar, 0.02 molar, saying 2.4 into 10 power minus 3. Third one, you are need of 3 rate equation because you are going to calculate it 2 order. Therefore, 3 is necessary. 0.02, 0.02, 9.6 into 10 power minus 3. And what is the rate constant of the reaction? They are not asking order of the reaction. There is not asking the rate equation, but they are asking what is the rate constant of the reaction. அவங்க மூணாவது ஸ்டெப்புக்கு போயிட்டாங்க. The options are A 1.2 into 10 power 3 per molar square per second. B 1.2 into 10 power minus 3 per molar square per second. C 1.2 into 10 power 3 mole square per second. D 1.2 into 10 power minus 3 mole square per second. To find the rate constant, we are in need of the rate law equation. To find the rate law equation for a given reaction, you are need of the order of the reaction. From the given set of the data, you should calculate the order of the reaction, applying the rate law equation. And by a shortcut method, we are going to see the concentration terms given. Take any two set of the reactions such that one concentration is remaining constant, the other concentration is varying. And if you take the 1 and 2 set of data, this A2 would be cancelled, and B2 is 2 times higher than this. Therefore, let us assume the B2 concentration. Let the order of the reaction of the B2 let it be N. It is converted to this is 2 times increase. Therefore, 2 power N is equal to the order is 2 times increase. Therefore, what is the order of the B2 reaction with respect to B2? N is equal to first order. Similarly, now you have to find out the order of the reaction, for which you have to choose two set of data such that the B concentration should be cancelled. Order with respect to A equal to second order, and with respect to B is first order, and total order is third order. And what is the rate law? Rate law is equal to K into A power 2 and B power 1. This is the rate law equation. You are not asked to find out the rate law, but they are asking you to calculate the rate constant. How to calculate the rate constant? For which rate constant A, you should know the rate, you should know the concentration of A, you should know the concentration of B. Then only you can calculate the rate constant. For which you can take any one of the data, apply this, you will get the K. Simplest form is the first one. The rate is equal to 1.2 into 10 power minus 3 equal to into the concentration of A is 0.01 square in the concentration of B is 0.01. Therefore, K would be equal to 1.2 into 10 power minus 3 divided by how much it would be there? 10 power minus 6. Do you follow this? 10 power minus 6 are equal to 1.2 into 10 power 3 is equal to K. Therefore, which answer is the correct answer? If you find the answer C is an answer, C, A is also an answer, but the units are different. Which is a correct one? You can find from this itself, or you can find it from the unit for the K equation, that is molar power 1 minus N. In our case, the total order of the reaction is here M plus N, because two reactants, M plus N, total order is 3. Therefore, molar power 1 minus 3 and molar power minus 2. Take down the next type of problem. Predict the rate law. Predict the rate law of the following reaction. Predict the rate law of the following reaction. Based on the data given below. Based on the data given below. Option எழுதிக்கோங்க. இந்த டேட்டா டேபிளை போட்டுக்கோங்க. Serial number 1, 2, 3, 4. Here A concentration and B concentration as the initial rate, and forget this molar per second. That is the unit always 0.1, and the rate is F. Second, 0.2, 0.1, 2x, 0.1, 0.2, 4x, and 0.2, 0.28x. The rate law is equal to A. Rate is equal to K into A power 2 into B. B option, rate is equal to K into A power 1 and B power 2. C, rate is equal to K into A power 1.5 and B power 0.5. D, rate is equal to K into A power 2 and B power 2, which is the correct answer. And looking at the problem, here you are need of only 2 orders, but here 4 set of data are given. You are not necessary for the 4th given, 3 set of data are sufficient. And looking into this first and second one, which concentration is varying? A concentration is very, the A concentration varies 2 times, therefore 2. Let's assume it's its order is M. The order is M. What would be the change in the rate of the reaction? That is equal to 2x divided by x equal to 2. Therefore, M is equal to 1. Here, look for, immediately see where is the 1 is there. Here only in one case the M is present. Therefore, this should be the correct answer. Choose the first and the 3. A would be cancelled. Its concentration is 2 power n times. Now you have to choose the third and the first one. It is equal to 4. Therefore, convert into the base 2, 2 power 2. Therefore, what is the n? N is equal to second order. Therefore, this is the rate constant. And all this can be done by mental sum like this. How to work out this? If you see, its concentration increases 2 times and the rate is increases 2 times. 2 times increase for 2 power something is 2 times. Therefore, its order should be only 1 time. If your concentration increases 2 times, the rate is increased by 4 times, the order is 2 times. The order is equal to 2. And so, if you work out various problems in this type of problem, and looking at this, you will easily say this is the rate law equation. Here, find this. What about this? Compared to, you have to take which one? The first and second, so that the other would be cancelled. 2 times increase in the concentration of B, but the rate is increased 4 times. Therefore, definitely the 2 power n is equal to 4 and n should be equal to 2. Therefore, without working this, you can give the rate equation. But if you are asked to calculate what is the rate constant, then you have to substitute and find out the ones. Now we will go to the next type of problem that may be asked in this type of order, the reaction. The rate law for a reaction. The rate law for the reaction. The reaction between A, B and L. A, B and L has been found to be K into found to be at rate law எழுதிக்கோங்க rate law rate is equal to K into A power 2 and B power 1 and L power 3 has. What happened to the rate of reaction? What happened to the rate of reaction if concentration of A is reduced to 1/3. And concentration of L is quadrupled. The concentration of L is quadrupled. Option 8 times increased. B, the constant rate is 8 by 9 times of the original rate. C, 9 by 8 times increase. Or D, 4 times decreased. 4 times increase means it is 1/4 of the original value. 4 times decreased. And how to find out this one? And you can see that A concentration is reduced to 1/3. Or you can apply this one. What is the rate of this reaction? Here, what is the rate of the reaction? Let it be R. R is equal to K into A power 2 into B and L power 3. What is the rate X when the concentration of A is 1/3 of the original into the concentration of B? They have saying nothing about the concentration of B, therefore we keep it as same concentration. And L is quadrupled, therefore now you have to find out the X. Therefore, this divided by this, R, X is unknown, keep it in the numerator and R in the denominator. You will get R by X. Cancel, cancel. This and A cancel. Therefore, it is 1/3 square. B and B cancel. L by L. Therefore, we are keeping this L above 1/4 into 3 halves. And you are in need of X. Therefore, என்ன செய்ய வேண்டியது? இதெல்லாம் உயர கொண்டு வாங்க. R into 1/3 whole square into 4 power 3 halves equal to into R is equal to X. R enjoy kochirikomo in the vortex. Okay, X. And if you increase this 1/9, and what about this 4 power 3 halves? What is equal to this one? You can easily say, you write it as 2 square power 3 halves. It is equivalent to what? 2 power 3 equivalent to 8. Or you can do one thing, 4 power 3 into 4 power half. What is the value of 4 power 3 half? I'm sorry. This is 4 power 1 into 4 power half. 4 power 1 is there and this is equal to 2. It is equal to 8. Or you can work out like this. 4 can be written as 2 power 2, power 3/2. This 2 and this 2 cancel. 2 power 2 equal to 8. Or you can also do like this. Therefore, it is 8/9 R. X is equal to 8/9. Therefore, initial rate, what is the initial rate? R is 8/9 times of R. Therefore, which is the correct answer? B is the correct answer. This is the way you can easily work out the last type of problem in this section. In a reaction, 3 reactants A, B, and C are reacted or participated. When the concentration of A is doubled, the rate of reaction concentration of A is doubled. A is doubled. The rate of the reaction increases to 8.2 times. The rate increases by 8.2 times. When the concentration of B is doubled, no effect. When the concentration of C is doubled, the rate of the reaction increases 2 times. Calculate the overall order of the reaction. Overall order of the reaction. Option is A, third order, B, 2.5 order, C, 1.5 order, D, second order. There is no effect. Therefore, what would be the order of the reaction? Order of the reaction, there is no effect means the order is
0.
0. It is doubled, the rate is also doubled. Therefore, what would be the order?
1.
When 2 power n is equal to 2, therefore n is equal to 1. Here, concentration is doubled, the rate is increased to 2.82 times. And what is the order with respect to this? It is doubled, therefore 2 power n is equal to 2.82. It can be rewritten as 2 into 1.41. That is nothing but 2 into root 2. It is equal to 2 power 3 halves. Therefore, n value is equal to 3 halves. Therefore, what is the total order? 2.5 order. And this one. Now, we will do some problem with this whole equation, that is rate law equation, how they are useful to calculate this one. Take down that problem in that. The reaction 2A plus B giving products follows first order kinetics. In each reactant. If the initial concentration of A and B are 1 molar, initial concentration of A and B are 1 molar each, the rate is found to be 10 power minus 2, 10 power minus 2 per molar per second, per molar per second. The rate of the reaction when the concentration of B comes down to 0.8 molar, comes down to 0.8 molar is option A, 4.8 into 10 power minus 3 per molar per second. B, 3.6 into 10 power minus 3, the same unit. C, 2.4 into 10 power minus 3, the same unit. And D, 1 into 10 power minus 2, the same unit. Here also, here is 2 set of data given. The rate of the reaction at one condition R1 is equal to K for the same reaction when the concentration is 1 molar power 1 into the concentration of B power 1 is equal to this one. This is the one condition given. given data is converted into this, and the rate is found to be instead of R1, to be just 10 power minus 2 per mole per second. 2A plus 1 giving the products. Initially, this 1 mole is present, 1 mole is present, 0 product. When the concentration is 0.8, the rate is equal to 10 power minus 2. The concentration of B is 0.8. What is the rate of the reaction they asked? When the concentration of B is given, but what is the concentration of A? They have not given. You have to calculate the concentration from this. What would be the concentration? You find out how to arrive at this. Here, what is the decrease in the concentration? 0.2 molar decreases. If B concentration decreases by 0.2 molar, what about the A concentration decreases according to stoichiometry? When 1 mole of B reacts, 2 moles of A is disappearing. Therefore, 2 times the disappearance of B. Therefore, it will be disappearing by 0.4. The remaining is 0.6. Now, what is the rate of the reaction? X is R. For the same rate, the rate constant is constant. The concentration of A is 0.6 power 1, 0.8 power 1. Now you have to calculate what is X. Once again, this is the equation number 2. You can put the unknown in the numerator by 10 power minus 2. This X get cancelled, equal to 0 by 1 into 0.8 into 1. Therefore, X is equal to 0.6 into 0.8 into 10 power minus 2. The answer is 4.8 into 10 power minus 3. Where it is given this one. Therefore, answer option A is correct one. If two 4.8s are given, look out the unit. In this unit, they may give a wrong unit for that one. And the next section, we will discuss rate equations. In the rate equation, we are going to calculate the half-life period of any reaction, half-life period or time taken for the 3/4 of conversion or any number of conversions. What types of problems they may be asking.
Thank you very much.
Thank you, sir.
Thank you, sir.